Hi, welcome to my channel JaberTime. Today I'm going to go over graphing quadratic equations given the standard form ax squared plus bx plus c. And I do have an example, as you could see, that we're going to go over and graph. Let's get started. For graphing quadratic functions of the standard form ax squared plus bx plus c, there's a few things that we need to know. If a is positive, a is greater than 0, the graph will open up. If a is negative, the graph will open down. C is going to be the y-intercept, and those are the main parts that will help us in the standard form to distinguish from other forms coming, the vertex form and the factor form. So C is the y-intercept, and A tells me if the graph opens up or down. The axis of symmetry will be x equal minus b over 2a. That's when we use also b in the middle, right here. The vertex will be minus b over 2a is the x coordinate, because the vertex is on the axis of symmetry, will have the same x value like the axis of symmetry, and the y-intercept, the y value will be its output, f of negative b over 2a. So once we find minus b over 2a, we need to plug it in the function itself and find its output. So in general, the standard form for quadratic equations is ax squared plus bx plus c. We don't want ax squared to be 0, because if it's 0, we're going to end up with linear only. So a cannot equal to be 0. The constant term is c. That is the y-intercept. And let's move on. Here I have two graphs. One opens down and one opens up. Let's talk about the domain and range. The domain for the function on the left comes from the x values, and the range comes from the y values that represents the graph, refers to the graph. The domain is always in quadratic equations, unless it's restricted, will be all real numbers, which means from negative infinity to positive infinity. That's this positive infinity and this negative infinity, where the range is from negative infinity all the way up to 3, including 3. That's the negative infinity, and that's the 3 level that we have, because the y value goes from this level down all the way up to 3, including 3. Let's go to the right side. The domain is still negative infinity to positive infinity, all real numbers. The range goes from this level all the way up, because it's the y values, and this level is when y equals negative 1. Cannot be below negative 1, and negative 1 is included in the graph. So the range is from negative 1, including negative 1, all the way up to positive infinity. Of course, open parenthesis always at infinity. The axis of symmetry is when x equal minus b over 2a. So this line right here is x equals minus b over 2a, where the graph is symmetric on its left and its right. So if you have a point like this one, that's the y-intercept, you could take the same distance, go to the other side from the line of symmetry, and mark this point instead of looking for points. Of course, the vertex will be the lowest point or the highest point on the graph, depending if it opens up or opens down. So here's a graph that opens up and a graph that opens down. This time we're going to talk about maximum and minimum. Maximum and minimum. If the graph opens down, we do have a maximum value. That's the y value. If the graph opens up, we do have a minimum value, and that's the lowest y value. Of course, that happens when a is positive, opens up, so you have a minimum, and when a is negative, the graph opens down, and then you have a maximum. Now we come to the question that we have. We need to find we need to graph it. Well, to graph it, we need to find enough details, as you could see right here. And then we'll talk about the vertex, the axis of symmetry, the domain, and range, and graph it. So let's have it in a new page and finish the problem. f of x equals x to the second plus 2x minus 3. A is 1. I know it's not mentioned, but we agree that this is 1 right here in front of x squared. That means a is positive, which means the graph opens up. B is 2. That's this 2 right here. C is negative 3. That's the constant right here. C equals negative 3, which means it's the y-intercept. So the graph is going to intersect the y-axis at 0, negative 3. Let's mark it before we lose it. 0, negative 3 is right here. That's the y-intercept, 0, negative 3. Y-intercept. Now let's find the axis of symmetry, which is minus b over 2a. To be careful, I'm going to use parentheses because sometimes we have negative numbers. The opposite of b is 2, over twice a is 1. That's minus 2 over 2, which is negative 1. So the axis of symmetry is x equals negative 1. It's a vertical line. That's the axis of symmetry. And it's going to be at this location. This is the axis of symmetry. X equals negative 1. To find the vertex, what we do is we plug in negative 1 right here into the equation to find the y value. So f of negative 1 equals negative 1 to the second plus 2 times negative 1 minus 3 equals 1. That's negative 1 to the second, which is positive 1. 2 times negative 1 is take away 2, take away 3. That's like 1, take away 5, which is minus 4. So the vertex is negative 1 comma negative 4. Let's mark it on the graph and point to it as our vertex. So this point is negative 1, negative 4, which is the vertex. Now, before I answer the domain range, let's graph it. To graph it, we could go and take this point and copy it to the left because of symmetry. We need more points, so I'm going to take this point right here I'm gonna take x equals 1. Let's go to the right side and plug in 1. When x equals 1, f of 1 equals 1 to the second plus 2 times 1 minus 3. That's 1 plus 2 minus 3. That's 3 minus 3, which is 0. So we do have 1 comma 0. Let's mark it. It's because of symmetry. I'm going to go to the left of the axis of symmetry, which is 2 units far apart. Take a look at this. These are 2 units. So I'm going to go to the left 2 units and mark another point, which is -3 comma 0. If you plug in -3, you'll end up with 0. Now let's graph it. So the graph is going to look like this. Symmetric about the axis of symmetry, and opens up, goes through the y-intercept -3, and now we're ready to answer or finish the problem answering the last 2 parts, domain and range. Now domain comes from the x values and the range comes from the y values. The domain is all real numbers because that's the case for parabolas. Goes all the way to the left and all the way to the right, all the way to the left and right. Range. Let's use a different color for range. I'll use blue. For range, it's the y values. And the y values, they go from this level all the way up. The graph does not go below y equals -4. That's the lowest point that we could have, the lowest value for y. So we go from -4 all the way up to positive infinity, and that positive infinity is what we refer to as up here, going up to positive infinity. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.